Every monsoon, many communities of South Bengal wait anxiously for the same warning signs. Rising river levels, heavy rainfall upstream, water entering agricultural fields, road connectivity being affected. For the people of Ghatal and Kanakul, flooding has been a recurring challenge for generations. But the question today is not only why flooding happens. The bigger question is, can scientific planning and integrated engineering create a safer future for these communities? Because flood management is not about fighting rivers. It is about understanding them. To understand the flood challenge, we first need to understand the river network. The rivers of this region are part of a connected hydraulic system. The Dorakiswar River and the Shilabadi River flow through this landscape and interact with the wider Rupnarayan River system. The Rupnarayan then continues downstream toward the Hooghly River before finally meeting the Bay of Bengal. This means flooding cannot be viewed as an isolated problem of one village, one town, or one river stretch. The entire basin responds together. A change upstream can influence conditions downstream. Therefore, the solution must also be connected. The flood challenge in this region is created by multiple interacting factors. First, the geography. Much of this area is low-lying floodplain terrain. Second, monsoon rainfall. During intense rainfall events, large volumes of water enter the river system within a short period. Third, river capacity. When incoming flow exceeds the carrying capacity of the river channels, water naturally spreads into surrounding areas. Fourth, drainage conditions. Even after river levels reduce, poor drainage can prolong waterlogging. Therefore, flood risk is not caused by a single reason. It is the result of hydrology, geography, river behavior, and human settlement patterns working together. Long-term flood resilience requires a comprehensive approach. A successful flood management strategy may include river improvement, hydraulic structures, drainage enhancement, flood protection measures, monitoring systems, and continuous maintenance. The objective is not to completely eliminate natural flooding. Rivers need space to function. The objective is to reduce the severity and duration of flood impacts on communities. Over time, rivers naturally change. Sediment deposition and morphological changes can reduce effective flow capacity. Therefore, scientific river management may require measures such as selective channel improvement, removal of critical flow restrictions, improvement of hydraulic capacity where necessary. However, every intervention must be supported by proper river studies, because increasing flow in one location can influence conditions elsewhere. A river is a connected system. Hydraulic structures such as weirs can become an important part of water level and flow management. A weir can influence water levels, flow distribution, hydraulic behavior during different seasons. But such structures must be planned carefully. Their effectiveness depends on understanding upstream conditions, downstream impacts, sediment movement, river morphology. A structure alone cannot solve flooding. It must become part of an integrated river management system. For communities living near rivers, Embankments remain an important protective measure, but an embankment is not a one-time solution. Its reliability depends on regular inspection, maintenance, strength assessment, emergency preparedness. The future of flood protection depends not only on building structures, but also on managing them effectively over time. River flooding is only one part of the challenge. Local drainage plays an equally important role. After heavy rainfall or river overflow, water must have a pathway to return. Therefore, a comprehensive plan should consider drainage channel improvement, pumping arrangements where required, removal of local bottlenecks, better connectivity between natural and engineered drainage systems. Flood management is successful only when water can enter, move, and leave the system efficiently. Modern flood management must move from reacting to floods toward predicting and preparing for them. Future-ready systems can include real-time rainfall monitoring, river level observation, flood forecasting models, early warning communication. Technology allows communities and authorities to act before the flood reaches its peak impact. The lessons from earlier WBFC episodes remain important. Flood resilience is strongest when engineering and natural systems work together. Rivers, floodplains, wetlands, drainage networks, hydraulic structures, all are connected. The future approach should not be only about controlling water. It should be about managing water intelligently. For generations, the people of Gatal and Kanakul have lived alongside rivers. The challenge today is to combine traditional understanding with modern science and engineering. Because floods cannot always be prevented, but flood risk can be reduced through better planning, better infrastructure, better monitoring, and better understanding of the river system. A safer future depends on creating harmony between communities and the rivers that shape their lives. Engineering Earth's Balance, Flowline Chronicles,